All right, class, welcome to Lab 11 for week 11. We're going to be going over your test review, and then we are also going to move on and talk about exponentials. All right, so for test review, the first equation that we're going to be looking at is x minus 1 over x minus 5. Okay, they want us to answer some of the following questions in complete sentences. Okay, so the very first one, it says explain how to find the domain of the function. So the domain, how do I find it? Well, the domain, I have to take I have to exclude, whenever I go to write my domain, I have to exclude the values that make the denominator equal to 0. Okay, so now exactly what does that look like for our equation? I have a denominator that is x minus 5. I set it equal to 0 and I solve, and I get x is 5, meaning that x cannot be 5 in my denominator because then it will give me a 0. So when I go to write my domain, I know that it's going to be from negative infinity to 5, union 5 to infinity. I just cannot include the 5. All right, for B, it says explain how to find the vertical asymptote. Well, the very simple way to do that, which is exactly what we just did, we are to set the denominator equal to 0. Right, so we already did that. We know that we are going to have a vertical asymptote at x equals 5, meaning that's where I'm going to have a dashed line on my graph. All right, for C, it says, what is the relationship between the domain of the function and the vertical asymptote? Well, the vertical asymptote will be excluded from the domain of the function. All right, just like I showed you up here, it'd be negative infinity to 5, union 5 to infinity. It is excluded in the domain. All right, for D is explain how to find the horizontal asymptote of the function. So the way that we actually go about doing it, we compare the degrees of the numerator and the denominator. All right, so in this case, we take a look at our variables. So if I look up at my original function, I have an x over an x, right? So I know I have x over x. If they are the same, right, we drop the variables and we look at the numbers in front of them, which happens to be 1, and we say that we have a horizontal asymptote at 1, or y equals 1. All right, it says explain how to find the x-intercept of the function. Well, this one's really easy. We already worked with the denominator, so now we, of course, just have to say set the numerator equal to 0. And you can add, then solve for x. So of course, what's my numerator? I believe it was x minus 1, yep. So all I have to do is say x minus 1 equals 0. I solve it and I get x is 1. So I have an actual point at 1, 0 in my graph. So we're putting words to everything that we've already done. All right, F says explain how to find the y-intercept of the function. Well, if you have figured out that there is a pattern so far with the constants at the end of my numerator and denominator, I look at the ratio of the constants of the numerator and the denominator. All right, so what does that look like, right? I had x minus 1 over x minus 5, so I look at the constants, which are negative 1 over negative 5, and I know that they simplify to become 1/5, so I know I have a point at 0, 1/5. All right, for G, it says, does the graph intersect the horizontal asymptote? Well, no. In this case, it does not. So we say no. We set the equation equal to, right? The reason why I know this is if I were to set the equation equal to the horizontal asymptote, the variables would end up canceling out. Well, what do I mean by that, right? If I take and I play x minus 1 over x minus 5 and I set it equal to the horizontal asymptote, which I got a 1, and I were to work this problem, right, I know I would have to move the denominator to the other side, so I would get x minus 1 equal to x minus 5. And if I were to solve by moving the x's to one side, they cancel each other out, and I'm left with negative 1 equals negative 5, which we know is not a true story. So we know that it will not intersect because of this. It's a simple little mathematical equation that helps me determine if and when it does. All right, it says, what is the multiplicity of the denominator and how does it affect the graph of the function? Well, the multiplicity determines if the graph approaches or approached asymptotes in the same direction. Another way to simply look at that is if it has a multiplicity, say we have a multiplicity of 3, what'll actually happen is it'll take and it'll bounce off the 3 and it creates a curve. But the more fancy way to say it is multiplicity determines if the graph approaches the asymptote in the same direction. All right, so it says graph the function. Okay, so we're going to take every single piece that we figured out. We know that we had a vertical asymptote at 5, right, because of the denominator. The horizontal asymptote, well, we said it was x equals 1. Why? Because x over x equals 1. We know that we had an x-intercept at 1, 0, and we had a y-intercept at 0 and 1/5. All right, so now we're going to graph everything. I'm going to draw my line at the 5, right, because that's my, let me darken that up. All right, so we are going to have my vertical asymptote. My horizontal is going to be at 1. And then, of course, I said I had a point at 1 and 0, 1/5, which, you know, it doesn't have to be accurate, but I know that it's right going to be somewhere between 0 and 1. All right, and now I'm going to take and I'm going to draw my line. Remember, I get really close to my asymptotes, but I don't actually cross, and I'm going to do the one opposite. So I'm also going to have one here. Now, if they wanted specific points, remember you just plug in a point to the left and to the right of the vertical asymptote. Now, for question 2, it says, is it possible to have a rational function with a vertical asymptote of x equals -4 and no horizontal asymptote. Now, I believe there is one situation, I think I showed you in our cheat sheet, right? If we did if we have x over x, we know that it's 1. If we had x squared over x squared, we know that it is also 1, or we take and we look at the numbers in the front, right? So that would actually be 1/2 if I had 1 over 2. And of course, if it was x over x squared, we know that that ended up being a 0. But there is an instance where if we had x squared over x, that actually is when we have none. We have no horizontal asymptote. So we can say if we have an x squared on top with an x on the bottom, and it says that the vertical asymptote, which if we remember, it's when we set the denominator equal to 0 and solve. Now I'm going to do it in reverse, right? I get x equals -4, move it back to the other side. So I know that my denominator has to be x plus 4. This is what my equation would look like. A very basic equation that follows the rules established within the equation or the question. All right, for question 3, we're going to solve the inequalities, and we're going to use the number line and interval notation. So, of course, first thing that we have to do is we have to solve, right? I know I'm going to have to pull out a 7x that they both have in common, so that I'm left with x minus 2 greater than 0. So we're going to draw our number line, right? We have a negative infinity to positive infinity. And then if we were to solve, we know that this is x0 and this is x equals 2. So we know that we're going to have a 0 here and a 2 here. And we're, of course, looking for where it's greater than 0. So we're looking for where the numbers are greater or positive. So what we're going to have to do is we're going to go into our graph, because I don't feel like having to do this by hand. And at no point in time did I tell you that you needed to do it by hand. So this is where we can use our calculator. And we're going to plug in 7x squared minus 14x. And we're going to take and we're going to look at our table. Oh, mine is still set by decimals, or 0.5. But change my table set back from 0.5 to a 1. And now I can look. First thing I'm going to look is I'm going to look to the left of 0, right? So I'm going to look for, it didn't change table set. Let me start at 1. There you go, 1 to 1. Perfect, okay. So I'm going to look to the left of 0, which would be -1, and it's positive. Oops. It's positive. I'm going to look from 0 to 2, which of course is +1. Well, that's negative. And then after 2, we're going to look at 3. That's also positive. Remember, we're looking for where it is greater than 0. So we know if we draw our greater than, we know it's going to have to be parentheses. And we know it's going to be everything from -infinity to 0 and 2 to infinity. So we're going to fill it in. And now we're going to draw our line. We're going to have negative, or our interval notation, which is -infinity to 0, union, negative, union 2 to infinity. All right, B. I'm going to have to factor. Or in this case, I will take and I will set this equal to 0 and solve, so that I get x to the power 4 is equal to 81. And I'm going to take the 4th root. And if you don't know this, you can take the 4th root in your calculator. Well, actually, no, I'm not going to teach you that way. Well, really, you have to realize that if you can't think of it that way, this is like saying square root of 81, square root of 81. So we know that if we were to do 81 to the power of 1/4, 3. My answer is plus or minus 3. If you don't like to do it that way, then you can also see that this is a difference of squares, where you get x squared minus 9, x squared plus 9. And of course that x squared minus 9 factors even further to get x minus 3, x plus 3 with an x squared plus 9 still, because we cannot do a sum of two squares. If I were to solve, I'm going to get an x is 3 and a negative 3. But this one right here, if I were to solve him, let me go to the side, I'll show you. If I were to solve him, I would move the 9 to the other side, and I would have to take the square root of a negative number, which would give me a plus or minus 3i, because you would have to pop out that negative and make it an I. And we cannot graph imaginary numbers on our number line. So what we have to do is just work with the 3 and the negative 3. So we have negative infinity. We're going to have our negative 3, 3, our infinity side. Again, I'm going to go into y equals, I'm going to put x to the power of 4 minus 81. I'm going to go to my table. I'm going to look to the left of negative 3, which is going to be negative 4, which is positive. I'm going to look between, so I'm going to look at 0, which is negative. And then to the right of 3, which is 4, it's going to be positive. And I'm looking for everything that is less than 0. So where are my answers negative? Well, it's between the negative 3 and 3. And because it is just less than, I know I'm going to have parentheses, and I'm going to fill it in on my number line. And then, of course, whenever I go to write it, it's from negative 3 to 3 with parentheses. All right, for C, I'm going to erase this guy here so I can work this problem. Remember, anytime that you're given the rational expression, you're going to set them both equal to 0 and solve. So if we were to solve x minus 2, we would get x is 2. And the denominator, because we can't get a 0, we know that it is x cannot be negative 3. So we're going to do our number line. We have our negative infinity. We have our infinity, and of course we have a negative 3, positive 2. And I'm going to go ahead and at my negative 3, I know that it cannot be that, so I'm going to go ahead and put my parentheses, just so that I know, because I'm dealing with a less than or equal to problem. All right, so again, go into y equals, clear it out. Remember, put the numerator in parentheses and the denominator in parentheses. So x minus 2 divided by x plus 3. Close out my parentheses and let's take a peek. Let's see, to the left of negative 3 is positive. Between negative 3 and 2, well, I choose 0, it's negative. And after 2, it's positive. Now, I want everything that is less than or equal to 0, so I know that it will be my negative numbers. It's going to be everything between negative 3 and 2. The 2 will have a bracket because he will be included, because he can be included. And when I go to write this, I know it will be a parentheses on the negative 3 side because it cannot be negative 3, to 2 with a bracket. Now for D, we don't have to solve the top because he's just a 1. But we know that x cannot be negative 10 when I solve the denominator. So I'm going to put my graph to infinity. I'm going to put my negative 10. And what's really nice is it's greater than 0. Well, if I go and I plug it in, I could easily figure this out without having to do anything. I just need to plug in, we'll say a 0 on this side to the right. If I were to plug it in, 1 over 0 plus 10, that's positive on that side, so that must be negative on this side. But to double check, I'll put in a negative 11, and of course that's 1 over negative 11 plus 10, which is 1 over negative 1, which is a negative answer. But we're looking for the positive answers, so we know that it's going to be a parentheses and it's everything above it. And now we go parentheses 10 to infinity. Close it out. Remember, you have a calculator at your disposal, so always use your calculator to double check. Always put your numerator, your entire numerator, in parentheses and your entire denominator in parentheses, and take your time on your test. Okay, use everything at your disposal and pay very close attention to what the instructor is asking of you.